discussing about how to realize the basic gate. We have three basic gates, NOT, AND, as well as OR. For these three gates, we have to realize by using Pspice simulator. In the lab, you have to realize by using there are different types of simulator. One is Pspice simulator, one is Xilinx simulator, say another one is by using HDL simulator. For the first week, we have to demonstrate by using Pspice simulator. Pspice simulator is a free version. It's available freely available in the Google. You download and you can install in your system for the practicing purpose. For all those material we uploaded in my YouTube channel as well as in my Google site. So whenever you should be go for the Pspice simulator, if you are already installed, then click on the start button. So you will get these three icons. You have to click on for schematics. So whenever you click schematics, you will get this window. So this window we have called the editor mode. So here we have to construct the circuit diagram for the NOT gate. So whenever I say the NOT gate, for this NOT gate, we have to know about the IC configuration also. For the NOT gate, the IC number is 7404. For this is the logic symbol for the NOT gate. We required one input and one output. For the input has to be provided by DG clock, digital clock. Then output has to be measured in terms of waveform. So the waveform will be getting the input is 0, output is 1. Input is 1, output is 0. So it depends upon that. We'll get an output in this format. So 0 and 1 fluctuation about output. That triggering has to be done. So the same thing we need to realize by using Pspice. Then the first step, go to draw, get new part. Then you have to click on the part name. What is the IC number? 7404. When you take 7404, you have to click on the place. You have to click here mouse. If you need one more, just you can click it. If you don't want, you just escape. For my program, only one is enough. Just select it and you can delete it. Then to connecting these, I require one more component as a input, DG clock. You take DG clock and you can place and close. If you don't want any more thing in this list, you just place and close that drop box is can. Only one input because of only one DG clock and end it. So if you want to get zoom, you can click on this zoom button. You can move anywhere, whichever you can move it. You can take it, you select it and can move like this. Okay. Then I need to connect this DG clock and this IC symbol. You have to take the wire and do the connection between this and these things. So then I want to get the output line also. Then I have to take one output line connected to the other end of the NOT gate. So once the line has to be connected, then I want to labeling the which one is an input and output. You take the voltage marker and you have to kept in this position, any position you can kept it. See in that line. If you don't want, press escape. Then click on, see you can labeling is V in the input voltage and V out for the output voltage to distinguish between input and output. The labeling is done. Then I have to give the input for the digital clock. Double click on that. You have to set on time 2 milliseconds. Save the attribute. Go to the off time 2 milliseconds. This is for the input providing to generate my waveform. Okay. Then click on OK. So after this setup analysis has to be done, I took a NOT gate 7404. I took DG clock, setting the input as 2 millisecond and off time is also 2 millisecond, input and output. Then save your schematics. We called as a schematics. Then save whatever you want as like C programming, not one. Then extension is .ch. By default, it will be save it and create your own folder in your system and save the file. After saving the file, I have to go for the analysis for the synthesis, the setup analysis. Click on the setup analysis. You have to click for the transient function. Click on that. Click this and I have to give the print step and final step. The print step is for each iteration, how many milliseconds has to be done from 0 milliseconds to what the transaction 10 milliseconds. What is the final time you've given? Till that it will be translating happens for the NOT gate. 0 millisecond, 10 millisecond, and you have to choose skip initial transfer function also. And click on OK, close. Once we're done for all those things, the next one, simulate. The simulator is called as a running. So when you've done everything, if you simulate, if you don't get any error, the waveform has to be get generated. See, observe the waveforms are generated. That will be come under the below of this taskbar. So whenever click this, you will get a waveform. So what is the waveform? See, observe 0 seconds to what? 10 milliseconds. We give final step as a 10 milliseconds. If you give 5, it will end up here only. Each iteration, 2 milliseconds on, 2 milliseconds off I given. See now, V in 0 and V out. Whenever my input is 0, you can observe the output is 1. Whenever my input is 1, my output is what? 0. 0, 1. Input is 0, output is 1. Then fluctuation of input and output we are getting in this one. Is it clear? See, this is once you're done, you can close the window, come back, and you can close this file for closing to start for the next program, or you can click on the exit button. See, this is for the first program to realization for basic gates. So the next class, we will learn about how to realizing for AND gate. Thank you.